the various types of compound formulae for Cambridge IGCSE Chemistry. Cambridge IGCSE expects the interpretation of compound formulae, knowledge of molecular formula, of empirical formula, and of how to obtain an ionic compound formula. Compounds are composed of two or more different elements chemically combined. Here are some named compounds: copper oxide, calcium chloride, sodium hydroxide. The elements combined in copper oxide are, of course, copper and oxygen. What elements are combined in calcium chloride and in sodium hydroxide? Pause, write down or speak out the elements combined. Restart to check. Okay, so calcium chloride, obviously calcium and chlorine. Sodium hydroxide, not so obviously. Sodium, hydrogen and oxygen, two or more different elements. The formula of sodium hydroxide is NaOH. Now, the formula of a compound such as calcium chloride is always the same, no matter the reaction in which it forms. So calcium chloride is where we combine calcium with chlorine to make calcium chloride. The formula of calcium chloride is CaCl2. But we could also make calcium chloride by reacting calcium oxide with hydrochloric acid to make calcium chloride and water. But the formula of calcium chloride is always the same. We have the same ratio of calcium to chlorine in a compound. In a mixture that of calcium and chlorine, the ratio would vary, but in the compound, the chemical combination is always the same, 1 calcium to 2 chlorines. So interpreting a compound formula such as H2O, the subscript 2 applies only to hydrogen. So we have 2 hydrogens. So if we look at a diagram, 2 hydrogen atoms combined with 1 oxygen atom. So the 2 refers to the hydrogen and not the oxygen. So we have 2 hydrogen atoms for 1 oxygen atom in the compound, and that is always true for water. Water is always H2O. So let's look at the compound carbon dioxide, and here is a diagram. 1 carbon, 2 oxygens. So the formula would be written as 1 carbon, 2 oxygens. The subscript 2 refers only to the oxygen and not to the carbon. So we have 1 carbon, but 2 oxygens. That is always true for carbon dioxide. It's always CO2. The interpretation of formulae in terms of the numbers of elements present in that formula is very important. So let's look at the example, hydrogen sulfate. I have a subscript 2 in front of the hydrogen, so 2 hydrogens. I have a capital S for sulfur, but no subscript number, so that's 1 sulfur. I've got capital O for oxygen with a subscript 4 in front, so that's 4 oxygens. Stop the class. What are the elements and their numbers in magnesium carbonate, lithium oxide, and magnesium hydroxide? Restart when you are ready to check your answers. Okay, so I'm going to reveal for magnesium carbonate, where we've got 1 magnesium, we've got 1 carbon, but there's a subscript 3 in front of the oxygen, so 3 oxygen. Lithium oxide, 2 lithiums, 1 oxygen. I hope that's straightforward. Magnesium hydroxide, different idea here. We've got a subscript 2 multiplying everything inside the bracket. So we have 1 magnesium, but oxygens inside the bracket, so 2 oxygens. We've got hydrogen inside the bracket, so the 2 multiplies the hydrogen as well, so 2 hydrogens. So the rule is that all elements inside a bracket are multiplied by the subscript after it. Let's now look at molecular formula and then empirical formula. Molecular formula refers to covalent compounds which usually form simple molecules, and therefore the formula is called molecular formula. And it's the number and type of atom in one molecule. For instance, sulfur dioxide, 1 sulfur and 2 oxygens. So that's 1 molecule of sulfur dioxide, the molecular formula SO2. Ethane, 2 carbons, 6 hydrogens in the 1 molecule. So the molecular formula C2H6. Displayed structural diagrams can be, or you're expected to be able to interpret those diagrams to produce the molecular formula of a particular compound. So here is an example. What is the molecular formula of this structural diagram? Okay, so I hope you've got your answer. Well, we've got 1, 2, 3 carbons. We've got 1, 2, 3, 4, 5, 6, 7, 8 hydrogens, 1 oxygen. So the molecular formula is the number and type of atom in one molecule, C3H8O. Here are 3 problems requiring you to interpret 3 different molecular representations. Each of them are hydrocarbons. The yellow atom is hydrogen, and in this diagram the black is carbon, and that's the case for propene. I've used the element symbols for benzene. Here are the 3 names. Can you give me the molecular formula in each case? Remember, the molecular formula is the number of atoms and type of atom in one molecule. Stop the class, come up with the molecular formula for each, and then start again and check your answer. Okay, so I hope you're ready. Methane, 4 hydrogens and 1 carbon, CH4, subscript 4 in front of the hydrogen. Propene, we've got 3 carbons and 6 hydrogens. Benzene, an A-level molecule, but nevertheless, you have the displayed diagram. It's easy to interpret, C6H6. Empirical formula. A molecular formula can be reinterpreted as an empirical formula. An empirical formula is the simplest whole number ratio of the different atoms in the molecule or compound. So I'm going to do this by example. Here's the molecular formula, C2H4. Well, we've got 2 carbons to 4 hydrogens. Well, the simplest or lowest whole number ratio isn't 2 to 4. I can divide 2 by 2 and 4 by 2 to give me 1 carbon to 2 hydrogens. So CH2 is the empirical formula, the simplest whole number ratio between the different atoms in the molecule or compound. So C4H8O2, so 4 to 8 to 2, well, I can divide through by 2 again to give me 2 to 4 to 1, so 2 carbons to 4 hydrogens to 1 oxygen. That's the empirical formula, the simplest whole number ratio. Here are 3 more. Can you work out the empirical formula in each case? Stop, restart when you are ready. Okay, so I hope you've done that. C4H10, well, I can't get a simpler number than that. The molecular formula and the empirical formula are the same. The ratio 4 to 10 can't be made any simpler using whole numbers. C6H12, well, I can divide through by 6 to give me 1 to 2. Now you'll notice that CH2 and CH2 are the same. They're the same empirical formula for different molecular formula. So an empirical formula is not necessarily unique to a particular molecule. C6H12O6, again, divide through by 6, gives me CH2O. So this you may recognize as glucose. So the empirical formula of glucose is CH2O. That's the simplest whole number ratio. So we'll finish with a simple treatment of ionic compound formulae. Ionic compounds form giant lattices, of course, which contain a large number of ions. So their formulae, for instance, magnesium oxide, are of course empirical formulae. So that means that they're the simplest whole number ratio of each type of ion. So here's a diagram of magnesium oxide. We count up the magnesiums, which are the blue ion, and oxygens, which are the green ion. We find there are 13 magnesium 2+ ions to 14 oxygen 2- ions in my diagram. So the ratio is 13 to 14. The simplest whole number ratio is, of course, 1 to 1. So the formula of magnesium oxide, the empirical formula, is MgO, a 1 to 1 ratio. So well done for finishing. If you want more practice, which I would advise, use your textbook questions first, then find past paper questions. If you haven't come across Physics and Maths Tutor website, I would recommend it. Nothing to do with me, it's just got loads and loads of past papers. For more related chemistry classes, look at the playlist or the links in this video description. If you found this class helpful, please recommend it to a friend. Subscribe for new classes and last-minute exam tips. Please like.